So, very good morning to all. Welcome back to Microbiology class. This is Dr. Rudrich. So, today I'll be discussing on a new chapter that is History of Microbiology. In this class, we will be discussing on historical developments in the field of microbiology. So, you may be knowing that although the microorganisms are the first living organisms formed on the earth around 3.5 billion years ago, that is around 1 billion years after the formation of earth, the actual science of microbiology is comparatively very new when you compare it to the other sciences. So because microorganisms were so minute, or people were unable to see their presence. So because they were minute, they could not able to see. There was not much studies in the field of microbiology for a very long time, although they are present among us in our environment for more than thousands of years. Okay. And the study of microorganisms was begun only after the development of microscopes. And you may be knowing that microscopes were developed only in mid of 17th century, around 1650s afterwards. Although in mid of 1650s and in 17th century, the microscopes were developed. So 200 years, for another 200 years until the mid part of 19th century, there was not much work happened in the field of microbiology. No research has happened. So that means to say that the science of microbiology or study on microorganisms was began only in 19th century, that in mid part of after the mid part of 19th century. That means to say that the actual science of microbiology is not more than 150 to 200 years. So it is comparatively a very new science. Okay. So although the study of microbiology or study of microorganisms is comparatively a new science, but we are living with the microorganisms since time immemorial. So since the beginning of human life, so we are living with microorganism and we are taking the advantage of the beneficial activities of microorganisms, and we at the same time we are also affected by bad effects of microorganisms. So initially in 19th century, when some of the great scientists like Louis Pasteur and Robert Koch started studying on microorganisms, so they initially the studies with microorganisms were largely carried out with respect to linking up several diseases that happen to human being to microorganisms. So Louis Pasteur and Robert Koch identified the causal organism of many diseases. They linked that, for example, cholera to Vibrio cholera, TB to tuberculosis, Mycobacterium febrae to tuberculosis, rabies to viruses. So like that, the initial studies were linked with the identification of causal microorganism for several human diseases. So in the beginning of microbiological studies, people started thinking that the microorganisms were enemies of human beings. So since they were telling that this microorganism will cause this disease, this microorganism will cause this disease, like that. But later on, with the improvement in the study of microorganisms, so people started believing that there are microorganisms which are beneficial to human being also. For example, later on scientists have identified that the microorganism present, they are also present in the air, in whatever the air we breathe. Microorganisms are also present in the water we drink. Microorganisms are also present in the soil. Microorganisms are ubiquitous, are present everywhere. And they have also identified that microorganisms are required for preparation of some of the food products like formation of curd, formation or preparation of pickle, or fermentation of wine. So, and not only that, so in the recent microbiological studies, some scientists have identified that many in many pharmaceutical industries, many medicines, so which can able to cure many several critical diseases are derived from microorganisms. And microorganisms have greater uh, advantages or greater utilities in industrial applications. So with this later discoveries, people started developing interest in the field of microbiology, and today, microbiology is a great interest to many scientists in the field of industries, medicine, agriculture. For example, in agriculture nowadays we are using many microorganisms as biopesticides, and even several microorganisms are also used as biofertilizer to enhance the plant nutrient availability like this. So, as of today, the microorganism has gained a great importance in the life of human beings. And although we identify the presence of microorganisms only around 200 years back, but I was telling you that we are taking the benefit of activity of microorganisms since time immemorial. For example, human beings were using yeast for leavening of bread for more than 2000 years. And also, we are preparing the curd from milk for more than 2000 to 3000 years, or even much before that. And even there were presence of several wineries in European countries for more than 2000 years. 2000 years. And also, people are knowing about the crop rotation. So when you rotate the pulse crops, cereal crops with pulses, the nutritional status of the soil was increasing. This is because the pulses will have a symbiotic association with an organism called rhizobium. So where in roots they form nodules, in nodules rhizobium will be present, and this rhizobium will fix the atmospheric nitrogen into the soil and enriches the soil nutrient availability. So although the scientific background behind the rotation of pulses after the cereals was not knowing, but they were knowing that, so it used to increase the soil fertility. So now we know that this is because the microorganism called nitrogen fixing organism, example rhizobium, will fix the nitrogen and enhance the availability of nitrogen and soil fertility status, which will benefit the next cereal crop. Okay. So with this, now we will we will study on some of the important scientists in the field of microbiology and their contributions. Okay, welcome back. And now we will discuss on some of the important scientists who have contributed greatly in the field of microbiology. So the first scientist we are discussing is Robert Hooke. So he is an English philosopher who was present in England during 17th century. So he is credited with the development of first microscope, especially the first compound microscope. So Robert Hooke is the first scientist who has developed a compound microscope. Compound microscope means the microscopes which are having more than one lenses. They are called as compound lenses. So you can see in this picture, this is the microscope that is developed by Robert Hooke. So he is an English philosopher. So this is a compound microscope where he had two lenses. We have used two lenses, one in the objective, which is called as an objective lens. So one is an eyepiece. So at the place where you observe through your eyes. So this is objective lens which is near to the specimen. So this is the, and he had a one blunt ending or a specimen holder, sorry, this is the specimen holder, and he also had a separate lamp for focusing the light rays onto the specimen so that you will see the specimen brighter. So although he is credited with the first scientist to develop a compound microscope, so his microscope was not giving much magnification. It was giving magnification only to the extent of 100 times. So with this microscope, he could not be able to observe bacteria clearly. So, but he observed fungal strands, fungal fruiting bodies. He has observed protozoa, algae, and other microorganisms. So, with curiosity, he has taken a section of the cork, bottle cork, and when he has observed under his microscope, so he could able to see this is the section of cork what he has observed. He could able to see a small tiny box type things. During that time, scientists were not knowing about the cell and importance of cell. So for small tiny boxes, what he has observed, he called them as cell. So he is also credited with the coining the term cell for the first time. So in mid part of 17th century, that is much before the uh, germ theory of, I'm sorry, much before cell theory was proposed by Theodore Swan in 1839. Okay. So this is about Robert Hooke. The next scientist we are discussing is Anthony van Leeuwenhoek. Anthony van Leeuwenhoek is a Dutch national. He is not a scientist. He has not studied much. He has done studies only up to his high schools, and he was working in a cloth shop, or some says that he is a cloth merchant. So during that time, or even now, people use lenses, binocular lenses, to observe the lining of the cloth. Well, to check the quality of the cloth and lining of the threads, they use binocular lenses. So Anthony van Leeuwenhoek, as a hobby, so he was making lenses. He was grinding the glass and blowing and making the lenses in his free time, in evening times. So as a hobby, so he has made he has made one small instrument like microscope for observing the small minute things. So this is his self-made microscope, which is made by Anthony van Leeuwenhoek. He has taken two brass plates, so with a hole at the center. So in this hole, he has placed a small lens, whatever he has built. You can see this his microscope is only 2 to 3 inches in height, and he has also put two screws, a lever, and a specimen holder. So these levers will help in the moving of the specimen front and back and also sideways so that you can able to adjust the focal point of the specimen. So with curiosity, Anthony van Leeuwenhoek observed several samples with his self-made microscope. So he has taken scrapes from the teeth. He has observed. He has taken push shells from the wounds. He has observed. He has taken sewage and observed. He has taken rainwater and observed. He has taken drinking water, juices, and many things he has taken and observed. So to his surprise, for the first time, he has observed many small animals which are moving rapidly inside these samples, whatever he has observed. He has made a drawings of all these animals, whatever he has seen. So these are some of the drawings, whatever he has made. So these drawings suggest these are the different types of bacteria having different shapes. So with his self-made microscope, so for the first time, he has observed all types of microorganisms. He has observed bacteria, he has observed fungi, he has observed protozoa, algae, everything. He has observed all types of microorganisms that in viable form, in living form. So since so he has made a good microscope which was giving a magnification around 300 to 400 times During that time, around 17th century, since he has observed all forms of microorganism in live form, so he is considered as father of microbiology. So Anthony van Leeuwenhoek is considered as is the father of microbiology. And whatever the observation he has made, so he has written that in Dutch language. During that time, there was a scientific publishing house in England, which is called as Royal Society of London. So Royal Society of London. So he has sent whatever Anthony van Leeuwenhoek written, he has sent that for publication in Proceedings of the Royal Society of London. Royal Society of London converted the Dutch language sent by Anthony van Leeuwenhoek into English, and it published in the Proceedings of Royal Society of England. And Robert Hooke also, whatever observation he has made, he has written in English and published in the Royal Society of London. And he was also the fellow of, Robert Hooke was also the fellow of Royal Society of London. So after the publications of Anthony van Leeuwenhoek, the world came to know that the other than plants, animals, and insects, there are also other animals or living organisms which cannot be seen through our naked eye are present in our nature. Okay. And whatever the microorganism he has made the observation, Anthony van Leeuwenhoek. So for the small microbes, so he called them as animalcules. Microbes observed by Anthony van Leeuwenhoek were called as animalcules. He referred them as animalcules. Later on, that came into existence. Okay. So after the discovery of animalcules by Anthony van Leeuwenhoek, so people started debating about the origin of microorganisms, how they might have come on the earth. So during that time, during the mid part of 17th century, so there was one theory proposed by Greek philosopher Aristotle, were believed by many people during that time. So Aristotle proposed the spontaneous generation theory or theory of abiogenesis, which means that some microorganisms form spontaneously from non-living organisms or non-living things. Sorry. So, for example, this theory of abiogenesis or spontaneous generation theory was proposed by Aristotle in 324 BC, and this was believed for more than 2000 years. People believed that some organisms formed spontaneously from non-living things. Some of the examples to support their theory, some of the examples given to support the spontaneous generation theory were the maggots. They believed that maggots arise from the rotting meat. They believe that maggots arise from the rotting meat. Mice or rats are spontaneously formed from carrion heap of a carrion waste. Flies. So these flies arise from rotting manures spontaneously. Fishes arise. Fishes arise or come from mud of the previously dried lake. So whenever in summers, majority of the ponds and lakes will be dry, right? So after the onset of monsoon, when rain comes and fills the ponds and lakes, so immediately after 3 to 4 days, you can able to see the moving of fishes. So where did these fishes comes? They say that they form spontaneously from the mud of the dried lake. So these are some of the examples that were given. So, but actually, maggots which are coming, they are coming from the eggs which were laid by the flies. People are not knowing about that. The mice which are coming from the heap of the carn waste or other thing, they might be present somewhere else. In search of the food, they might have come and entered inside. So whenever they come out, people thought that they are formed spontaneously from carn waste. Similarly, the fishes from the dried mud of the lakes. So the mud might have contained the eggs which were laid by the previously present fishes. So which were present in dormant form because the lakes were dried. because the lakes were dry. So whenever rain comes, whenever favorable condition had come, so the eggs might have hatched and the young ones might have come out. That's the reason. So it is not that some organisms form spontaneously from corn waste or manures or rotting meat or from mud of the previously dried lakes or ponds. So, but people were believing about this for more than 2000 years. There was many people were strong supporters of Aristotle. But many scientists during that time they believed that so spontaneous generation theory was not correct, and they tried several experiments to disprove the spontaneous generation theory. So one among the first scientists who started an experiment or done an experiment to disprove the spontaneous generation theory was Francisco Redi. So Francisco Redi is an Italian physician. He was a doctor in Italy during 17th century. He has done one simple experiment to disprove the spontaneous generation theory. So what he has done is, so he has taken a three jars. So in these three jars, so he has taken freshly cut meat pieces. Freshly cut meat pieces were kept in three jars. So one of the jar mouth was kept open. One of the mouth was sealed with a cork, and another mouth was covered with a cloth with a rubber band. So after a few days, when he has observed, we could able to see the maggots coming out of the rotting meat in the jar which was whose mouth was open, and there was no sign of maggots in the jar which was sealed with a cork. And in cloth covered jar, so he could able to observe the eggs which were laid on the cloth, and also the flies which were present in near the eggs. So with these, he concluded and said that so maggots are not formed spontaneously from rotting meat. So they were these the eggs were laid by the flies, and these eggs, when they hatch, the maggots will come out. So he said that I clearly disprove the spontaneous generation theory. And there was one scientist who was called John Needham. He is also an English national who was present at the same time. And after who was observing the work of Francisco Redi, he immediately commented that no, 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 this may not be true. Let me prove the spontaneous generation theory. I will prove spontaneous generation theory, saying that so uh, he has taken some nutrient rich materials like chicken soup or a meat soup. So he has heated that. John Nidam, he has heated that. After eating that one, he kept it like that. I kept it like that for a few days. After a few days, there was a development of turbidity and foul smell. So when during that time, microscopes were discovered. When he observed that microscope under microscope, he could be able to see the animal cues. So he said that. So see, I have heated to kill all the organisms which were present. Still, there is a development of turbidity and formation of animal cues. So I proved the spontaneous generation theory. So spontaneous generation theory is still there, whatever the John Needham said. So there was another scientist, Italian botanist, who is called Lazzaro Spallanzani, so who was observing the experiments of both John Needham and Francisco Redi. So he felt that whatever John Needham done, the heating of the chicken soup may not be proper. He might have not heated this properly. So he has done his own experiment. So Lazzaro Spallanzani has done a simple experiment. He has taken two jars. So he has taken two jars or two flasks. So he heated them. Two flasks, he heated them well enough to kill all the organism. After heating, so he has sealed the mouth of the one flask with a cork, and he has left open the another cork. I'm sorry, another flask without covering the mouth. Same thing. After some time, the flask which was open, whose mouth was open, turned in, got turbidity, developed turbidity and small small, and microorganisms were developed. Whereas the flask which was sealed didn't develop turbidity, so there was no formation of animalcules. With this, he has said that, so I disprove the spontaneous generation theory. So this time again, John Needham, a strong supporter of spontaneous generation theory, he commented that. So you have sealed the mouth of the flask. So by sealing the mouth of the flask, you have deprived the entry of air. And air is the vital force which is required for the formation of a life. So air is a vital force required for the formation of a life. So by sealing the flask, you have deprived the formation of life. Therefore, we cannot accept your experiment and we cannot ignore the spontaneous generation theory. So that is what John Needham said. So he didn't accept this experiment. Later on, so around in 19th century, French Academy of Sciences floated on contest to disprove the spontaneous generation theory. They floated a contest with the prize money. So whoever disprove the spontaneous generation theory, we will give the prize. So during that time, Louis Pasteur, a chemist, so he has entered this contest. He has tried to disprove the spontaneous generation theory. So with one simple and clever experiment, he has disproved the spontaneous generation theory, and he has he has sent the spontaneous generation theory to rest. So what he has done is he has taken normal flask, round bottom flask. So in this round bottom flask, similar to Lazarus Palangeni and Francisco Reddy, he has also taken nutrition rich material, that is chicken infusion or chicken broth or beet broth. So before setting up this experiment, what he has done, he has heated the mouth. He has heated the mouth of the flask and he has drawn that into a shape. He has drawn the mouth of the flask into an S shape or like a swan neck. Like a swan neck. After that, he has heated the flask. After making it into a S shape, he has heated both the flasks and he has kept both the flasks for incubation. So even after months, several months, there was no development of turbidity. But here, there is an entry of air. Air is entering here. But there is no contamination from bacteria. So, even after several months, there was no development of turbidity. But whenever he has bent that one, so that the liquid comes to till the mouth, or whenever he has broken the mouth of the flask, so immediately there was a development of turbidity and animalcules were growing. So with this experiment, so he has disproved the spontaneous generation theory. So here he has allowed the entry of air. He has allowed the entry of air. Still there was a no growth of microorganism with this. So he has also allowed the vital force that is here, and he has also restricted the movement of microorganism, and he disproved the spontaneous generation theory. No, this is how Louis Pasteur disproved the spontaneous generation theory. But now, so before doing this experiment, Louis Pasteur also proved that air is full of microorganisms. For the first time, Louis Pasteur proved that air contains microorganisms. He has taken one simple glass tube. He has put cotton plug in one end, so gun cotton especially. So he has moved with force. He has moved air from one end to the another end. So whatever is blocked in the cotton, he has taken that cotton, he has dissolved in ether and alkali solution. So whatever that is satellites which are present at the bottom, so that when he observed, he could able to see the similar things, similar organisms, similar to animalcules reported earlier. So with this, he say that air is full of microorganisms. Now he also before starting his experiment, so he thought that there should be entry of air, but microorganisms should not enter inside. For this, what he has done is he has bent the mouth by heating. He has bent the mouth into S shape. So when he has bent the mouth into S shape, what will happen is, so when the air is moving here, So air will be carrying the microorganism. The microorganism in the air will be present in the soil particle. The soil particle, whatever is present in the air, soil particle and water vapor, they will be carrying microorganisms. So these soil particles, microorganism or water vapor, they are heavier than air. So only when there is some kind of velocity or it is air is moving with particular speed, it can able to carry soil particles or microorganisms. If the velocity of the air will become very low or it starts moving, so the whatever the heavier particles, including microorganisms which are heavier than air, will fall down. Same principle was applied here. So when the air is moving here, it is moving downward direction with a particular velocity. So suddenly there is a change in direction. The air which is moving downward has to change its direction and move upward. During this change, what will happen? Before changing the direction, the velocity of the air become almost zero. So when the velocity, when air stops moving for a fraction of seconds, what will happen? The soil particles that are present in the air will get dropped here. So afterwards, again slowly air start moving here. So again, here there is a change in direction. The air which is moving up has to come down. For direction, it has to change suddenly to downward direction. Here again, the velocity of the air comes to zero for a fraction of a second. So during that time, whatever the particles which are there in the air will drop down. So and microbial free air will enter inside the flask. But whenever you touch this one, whenever you touch this liquid too, so until here mouth, so the microorganism present here will go inside and start growing. So this is the principle. This is how Louis Pasteur disproved the spontaneous generation theory. So this is enough for today. So we will continue about the history of microbiology in the next class. Thank you.